Okay, I hear the recording in progress. So go ahead and get started here. All right, so we had our one-day weekend yesterday, so to speak. Another one coming up. Okay, so the original plan was only to cover 4.2 this entire week, but I've already finished it. So we're probably not going to meet that long today at all. I am getting started with 4.3, which wasn't going to be until next Monday, the 18th. So quiz tomorrow, just 4.2 material, but I'm sneaking in some of 4.3 right now. And looking way ahead, next exam is Friday, the 5th of November, it looks like. Okay, and yes, sneak in 4.9 in here as in the original handout. I did not put 4.9, but of course it belongs there. Okay, so I will sneak in some of 4.3. We probably will end somewhat early. Anything I do now is actually just gravy. It's just extra since it was not supposed to be done until here. Okay. All right, and tomorrow you get a quiz on 4.2 stuff. All right. So 4.3 is a review of right triangle trigonometry, which means you're going to have right triangles. Okay. So A, B, C, Pythagorean theorem applies. Here's a right angle. Here's an angle theta. So among other things, we know that A squared plus B squared equals C squared. Okay, on page 202, we have the definitions of the trig functions here. They're all correct, but I'll give you my version, which may be similar to what you've heard before, maybe when you took trig in your previous classes. Here's a nice little table in degrees and radians of key values. Okay, so sine goes 0, 1/2, radical 2 over 2, radical 3 over 2, 1, as it goes 0, 30, 45, 60, and 90 degrees. Radians are 0, pi over 6, pi over 4, pi over 3, pi over 2. The cosine of angles, you can just kind of reverse all of these. See how these goes up? Cosine just kind of goes down. So 1, radical 3 over 2, radical 2 over 2, 1/2, and 0. Okay. All right, let me show you the homework problems, which were just 1 to 25 odd. Let me mark this off here. 1 to 25 odd. Page 206. Let me show you more here. Okay, and then on this side, and then 25 looks like it's over here. Okay. Okay, so my take on right triangle trigonometry. Draw myself a right triangle, right angle, theta. So first some definitions. From a given angle, which is not the 90-degree angle, if I go across over here, that's the opposite side, which I've abbreviated as OPP. Okay, I decided not to put opposite because, again, I think you've heard that before. This is not the first time you've heard it. If this were the first time you've ever heard it, I would write the whole word OPPOSITE. Since you've seen it before, opposite OPP. And ADJ for adjacent, HYP for hypotenuse. Okay, so we have the opposite side, the adjacent side, and the hypotenuse, right? Adjacent meaning next to. And by the way, you might say, well, isn't this one also next to it? Yes, but this already has a name for it, hypotenuse, right? So for the adjacent side, it's a side next to the angle that isn't the hypotenuse, because one of them will be the hypotenuse, the other is not the hypotenuse, right? The hypotenuse already has a name, hypotenuse. So the adjacent side is a side next to the angle, but is not the adjacent side. Okay, then you've probably heard of SOHCAHTOA maybe. If you haven't, that's okay. So what is SOHCAHTOA? Sine is the opposite over the hypotenuse. Sine of theta is the opposite over the hypotenuse. Ka, C-A-H, cosine of theta, adjacent over hypotenuse. Toa, tangent of theta, opposite over adjacent. So these are the ratios in a right triangle. Right, so sine of theta, opposite over hypotenuse. S-O-H, sine, opposite over hypotenuse. Ka, C-A-H, cosine of theta is the adjacent over the hypotenuse. Tangent of theta is the opposite over the adjacent. You may put these on your cheat sheet, although if we were meeting face-to-face in pre-pandemic situation, I would make you guys memorize it. I think a lot of you already have this memorized anyway. And then the reciprocal functions, you can put these on your next cheat sheet. Cotangent theta is the reciprocal of the tangent of theta. Secant of theta is the reciprocal of the cosine, 1 over cosine theta. And cosecant of theta is 1 over the sine of theta. Right? Okay. And again, put these on your cheat sheet, but if we were meeting face-to-face, I'd make you guys memorize it. One thing worthy of note, if one trig function has a co, CO, the reciprocal does not have a co. So notice co, tangent, tangent. Secant, there's no co, so cosine. Cosecant, there's a co, so its reciprocal is sine. That's if I were to make you memorize all of these, which I'm not, but in case, next semester your teacher makes you memorize all these, that's a memory trick. If one function has a co, the reciprocal does not have a co. Tangent, cotangent. Co, no co. Cosine, secant. Co, no co. Cosecant, sine. Co, no co. All right, then a little bit of right triangle trigonometry to get you these values here. So this is all theoretical right now. So how do they come up with these values? Okay, so I'll show you. Let me start with a 45, 45, 90 right triangle. You might recall that in your geometry, perhaps. It's an isosceles right triangle. I decided to call the hypotenuse 1 just because it makes it easier. That's true in a unit circle. So both of these are x. So x squared plus x squared equals 1 squared, Pythagorean theorem. 2x squared equals 1. Divide by 2, x squared equals a half. Square root, square root. Normally you would do plus or minus, but these are distances. Distances are always positive. So x is the square root of a half. Multiply top and bottom by radical 2 over 2. Okay, so each of these is radical 2 over 2. What that means, among other things, is if I take the sine of 45 degrees, sine is opposite over hypotenuse. It's radical 2 over 2 divided by 1. Well, that's just radical 2 over 2. So that proves the sine of 45 degrees is radical 2 over 2. 45 degrees is the same as pi over 4 if you do the conversion factor. And then notice cosine is also radical 2 over 2 at a 45-degree angle. So cosine of 45 degrees is adjacent over hypotenuse, or the adjacent is still radical 2 over 2. So radical 2 over 2 divided by 1 is still radical 2 over 2. So that's the reason why cosine of 45 degrees is also radical 2 over 2. Okay, how do I come up with 30 and 60-degree marks? So I start off with an equilateral triangle. all the sides are 1, 1, 1, and 1. There's a 1 down here. I'm intentionally covering it up. Now, if all 3 sides are the same, that means all 3 angles are the same. We know a property of triangles is that the 3 angles have to add up to 180 degrees. So if this angle, and this angle all add up to 180, there's 3 of them. That means each one is 60, right? So 60, 60, and this is 60. I'm just not writing it. Then I draw a perpendicular from this vertex straight down over here. Come straight down, which means this, which used to be 60, cuts into 2 30-degree angles, right? This distance here was 1. I came straight down, cut it in half. So each of these is now a half. So here's my picture, right? 60, 60, 60, but if I cut it in half, now each of these is 30. 1, 1, and this is 1, but if I cut it in half, then each of these is a half. Okay. I now want the height of the triangle. Pythagorean theorem. I can use this triangle. I could also use the one on the left, it's equivalent. But by Pythagorean theorem, 1/2 squared plus h squared equals 1 squared. This thing squared plus this thing squared is this thing squared. 1/2 squared is 1/4. 1 squared is 1. So 1/4 plus h squared equals 1. Subtract 1/4. H squared equals 3/4. Square root, square root. Don't need a plus or minus. These are all distances. Square root of 3, just leave it alone, but the square root of 4 is 2. So the height of this triangle is radical 3/2. Right, so if I extract out just this triangle on the right side now, throw out this one, my picture now looks like this. Okay, so this is the right side right here. I'm just throwing out this left side triangle. But everything here matches this. Okay. Let's take the 30-degree angle. What is the sine of 30 degrees? So sine, opposite over hypotenuse. 1/2 divided by 1, 1/2. Sine of 30 degrees, 1/2. Cosine of 30 degrees, radical 3/2. There's 30 degrees. Adjacent, here it is, over hypotenuse. Radical 3/2 divided by 1, radical 3/2. So that's that. Now, 60 degrees, looks like these two guys are just reversed. This is 1/2 radical 3/2. This is reversed, radical 3/2, 1/2. If you look at the right triangle, that actually makes perfect sense. Let's try that. Here's 60 degrees, right? Sine of 60 degrees. Opposite over hypotenuse. Sine, SOHCAHTOA, opposite over hypotenuse. So sine of 60 degrees, radical 3/2 divided by 1. Well, if I divide by 1, it's still radical 3/2. 60 degrees sine, radical 3/2. Cosine of 60 degrees looks like a half. Let's see why. Cosine, whoops. Cosine of 60 degrees. Cosine is adjacent over the hypotenuse. So adjacent is a half, divided by the hypotenuse, which is 1, well, stays a half. So that's how come cosine of 60 degrees is a half. Now, you may not have understood anything I did over here. This is a proof of all of these. If you didn't follow every little detail, that's okay. I just want you to be able to use this chart pretty much. So I've actually derived for you these three middle ones, 30 degrees, 45, 60 degrees. Okay. And you might say, what about 0 and 90 and so on? Okay, so that's where we have to use the unit circle definition.
That's all we really have to know though, right? Is the unit circle. Like we don't ever have to recreate any of this. We just need to know the unit circle.
If you know the unit circle, it pretty much gives it to you, right? And okay. I'll show you the unit circle now. Right, unit circle means a circle centered at the origin and a radius of 1. Its equation is x squared plus y squared equals 1. So that means, among other things, this is the point 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Okay. Now, at all the angles that have a reference angle of 45 degrees, that's here, 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 and here. We'll talk more about reference angles later. But right there, you go up 45 degrees, right? So we start here and then come up to 45 degrees. And if we go this way, whoops. If we go this way, 45 degrees. We'll come down that way or that way. Both the x and y coordinates are always going to be radical 2 over 2. No exception. Radical 2 over 2, radical 2 over 2. The only thing you have to watch out for is the sign, S-I-G-N. And then you just follow the rules of each quadrant. So notice right there, 45 degrees. Right there, that would be what, 135 degrees? 225, 315. It's actually easier in radians, I think. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 2 pi. Okay. So all I did was I just plunked down radical 2 over 2 for both of them, x and y. And then I just consider the signs, S-I-G-N, not S-I-N-E. So first quadrant. So I think to myself, okay, first quadrant, both x and y are positive. Second quadrant, let's see, second quadrant, x is negative, y is positive. So I put a minus there and leave that positive. Somewhat logical, I think. Okay, then I think third quadrant. Well, third quadrant, both x and y are negative. So minus radical 2 over 2, minus radical 2 over 2. I'm not sure you can see that. But these are both negative radical 2 over 2. And that angle is 5 pi over 4. And finally, quadrant 4. Quadrant 4, x is positive, y is negative. So positive, negative, radical 2 over 2, negative radical 2 over 2. Okay. Now, here's another key point. On a unit circle, x comma y is the same as cosine theta, sine theta. You say, what's the cosine of the angle or the sine of the angle? It's simply the x coordinate or the y coordinate along unit circle. So, among other things, this is the point radical 3 over 2, comma a half. And by the way, you might say, how do you know that? Okay, radical 3 over 2 is way more than a half. I think it's like 0.866. Here, let me try that for you quickly on my calculator. Square root of 3 divided by 2. 0.866. It's way more than half. If you pick an angle that has a reference angle of either 30 or 60 degrees, either the x or the y coordinate is halfway across the circle. It's always true. Okay, so if I look over here, if I look at the x coordinate, well, that looks like more than half, but the y coordinate is about halfway. So I put y as a half. Now take a look at this. Y looks like it's more than halfway, but x looks like it's going halfway across the circle. So x is a half, and 1/2 is always paired with radical 3 over 2. No exceptions. Radical 3 over 2 right here. That means if I want cosine or sine of 30 degrees, I just want the x coordinate and y coordinate. Okay, so 30 degrees, x coordinate, radical 3/2. 30 degrees, x coordinate. Cosine means x coordinate. Sine is a y coordinate, 1/2. Oops. 1/2. See how it looks like this point is halfway up the circle? Now at 60 degrees, it looks like they reverse. X coordinate is 1/2. Cosine of 60 degrees. 60 degrees, cosine, 1/2. And yes, on the unit circle, 1/2 is always paired with radical 3/2. Y coordinate right here, radical 3/2. It works. So here we go. All right, now, getting back to this table, I've talked about 30, 45, 60. What about 0 and 90? Sometimes called the quadrantal angles. They separate the quadrants. Zero degrees or radians, and 90 degrees or pi/2. Those are called quadrantal angles. It's every 90 degrees. So 0, 90, 180, 270, 360, and so on. Those are called the quadrantal angles. You're not going to get a triangle out of it. Let's play the game of x and y coordinate. Okay, so how about at 0 degrees, which is the same as 0 radians? Zero degrees, right? The point is 1, 0. Cosine, comma, sine, x, comma, y. You can put it on your cheat sheet, but my memory trick was that they're alphabetical order. If you forget now, which one is cosine, which one's sine? Alphabetical order. X is before y, cosine is before sine, right? So if I play that game, I know, oh yeah, x is cosine theta, y is sine theta. Well, what's the x coordinate? 1. Y coordinate? 0. So the cosine of 0 is 1. Sine of 0 is 0. Zero degrees, which is the same as 0 radians. Sine is 0, 0. Cosine of 0 is 1. Just the x and y coordinate. Now let's take a look at 90 degrees. It goes 1, 0. How did I get that? So unit circle again. 90 degrees is right here, right? So here's the point in question, 0, 1. What is the x coordinate? 0. Y coordinate? 1. Which tells me cosine of 90 degrees should be 0. Sine of 90 degrees, 1. Here. And of course, you can keep going all the way around the circle if you wish. That's basically it. So for instance, cosine of 180 degrees. So I think to myself, okay, 180 is for cosine x coordinate, -1. So cosine of 180 is -1. How about sine of 180 degrees? Y coordinate, 0. Okay. See if we can demonstrate that to you in my calculator. Should have to be in degree mode. Okay. Cosine 180, -1. Cosine 180, -1. X coordinate. Y coordinate, 0. Sine 180, 0, as you would expect. Okay, so that's the idea there. Okay, so you want to think of this picture if possible, right? On a unit circle, x comma y is the same as cosine theta, sine theta, where x is cosine theta, y is sine theta. And we have these special angles. Okay. So let's see, I probably won't go much longer. Maybe just an introductory problem. Number 1, find the value of the 6 trigonometric functions of the angle theta. So they give me a 2 square root of 21. I got to figure out the hypotenuse. And then just do my SOHCAHTOA. And that'll pretty much about it. Yeah. Let me show you that and the setup. Okay, folks, I'll be done in probably 5 minutes or less. In which case, you can ask me stuff or put it in the chat. But if not, then we'll just end early and we'll be good. Okay, so a quick review. Theta, right angle, opposite, hypotenuse, adjacent. So SOHCAHTOA, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And here are the reciprocal rules. Reciprocal of the secant is the cosine. Secant of theta is 1 over cosine theta. Reciprocal of the cosecant is sine. And most students don't mix this up. Tangent and cotangent, pretty obvious. Right, so the original number 1 did not give me the hypotenuse. Radical 21, 2, and some theta there. So first thing I'm going to do is find the hypotenuse. A squared plus b squared equals c squared. So 2 squared plus radical 21 squared is equal to c squared. That should be easy. 4 plus 21 is c squared. C squared equals 25. Square root property. C is plus or minus 5. But for this kind of word problem, we don't want any negatives. So just keep the positive. 5. Right, so for some of these problems, they don't give you all 3 of the sides. You have to figure it out, right? Use the Pythagorean theorem to figure out this and so on, right? Okay, so SOHCAHTOA. Sine of theta is opposite over hypotenuse. So opposite is 2, hypotenuse is 5. Oops. So sine of theta is 2/5. Cosine theta, how to get radical 21 over 5. So cosine is adjacent over hypotenuse. Where'd it go? Yeah. Okay. So adjacent over hypotenuse, radical 21 over 5. Tangent, TOA, opposite over adjacent, 2 divided by radical 21. And that's it, the rest are just flips. So cosecant theta, flip this guy, 5 over 2. Secant theta, see, I'm getting a message, your meeting will end in 10 minutes. I think the Zoom somehow is back to only the 40-minute limit. Anyway, I think I'll be done shortly, but it's not the way it's supposed to be, but anyway. So secant, I just flipped this. So 5 over radical 21. You can rationalize it now if you want. 5 radical 21 over 21. And cosine, cotangent theta, just flip this. Radical 21 over 2. That's pretty much about it. Okay. All right. Okay, I'm pretty much done, folks. So I've only done one problem in 4.3, but again, we're just getting ahead. Everything's gravy at this stage, so to speak. And I wasn't supposed to start 4.3 until Monday. So write a little about 4.3 here and 4.3 here. So quiz tomorrow. And then we'll go from there. All right, I'm done for the day, folks. Looks like Zoom won't let me go more than another 7 minutes or so. So let me stop the share and check the chat. But otherwise, we're going to be finished. Okay, I don't see anything in the chat. Okay, any questions, please? Otherwise, we're done for the day. All right, that'll do it for today, folks. Okay, so have a good day, and we'll see you next time. Okay, bye, everybody.